Today we're going to be looking at motion and how the x and y components are completely independent of each other. If you shoot a bullet horizontally and drop another one straight down, which do you think would hit the ground first if they started at the same height?
Most people would think the bullet that was shot sideways, but they would be wrong. The answer is actually that they will land at the same time. This is because the horizontal component of the bullet's motion does not affect the vertical component of it, and the vertical component for both bullets are the same, gravity. To prove this, we set up a projectile motion lab where we launched one metal ball in its horizontal path down and dropped another metal ball straight down with no horizontal movement at all.
In order to do this, we gathered our equipment, which consisted of an electric scale, a projectile launcher, a C-clamp, a stand, a smaller base, carbon paper, and 2 small metal balls, one of which had a small hook attached to the top. First, we calculated the rough distance that the ball would land away from the contraption, then set up the base there, with carbon paper above it so that we could record where the ball landed.
We also recorded our data. For instance, we measured the weight of both balls, the height of the stand, and the force that would be applying to the horizontal ball. The reason for this base was because the hook that the ball falling straight down had put it slightly below the ball being launched horizontally, and thus it would hit the ground faster because it was closer to the ground. Therefore, we raised the ground for the launch ball to make up for this discrepancy.
We clamped the stand down, attached the projectile launching device, and released both balls. We started the stopwatch as soon as they were released and timed how long it took for them to hit the surface.
As mentioned before, x and y components are completely independent of each other. In both cases of horizontal projectile motion and projectile motion launched in an angle, the x component's velocity is constant, while the y component's velocity changes. The equations for each component are: for x component, distance equal velocity multiplied by time of x component. For y component, there are 3 parts. 1. Distance equals initial distance of y plus initial velocity of y multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. 2. Final velocity of y squared equals initial velocity of y squared plus 2 times acceleration multiplied by distance y. 3. Final velocity of y equals initial velocity of y plus acceleration times. Remember that the only thing similar between these two components is the time in air. The t it is going up and down is the same t moving sideways. So predict where to place the carbon paper that will mark the landing point. We used the following calculations above. The following given in our lab were Vx equals 0.2 meters per second. Bi equals 0 meters per second. Dy equals 0.38 meters. We shot this at an angle of 0 degrees. And we predicted using the equation t in air. Distance equals initial distance of y plus initial velocity of y multiplied by time plus 1/2 multiplied by acceleration multiplied by time squared. Time came out as 0.88 seconds. Dx traveled. Distance equals velocity x times time. Dx equals 0.176 meters. So we predicted the marble will land at about 0.176 meters. And the actual data shows. Distance in meters. 1. 0.170 meters. 2. 0.175 meters. 3. 0.184 meters. 4. 0.181 meters. 5. 0.180 meters. Average 0.176 meters. Total 0.89 meters.
In conclusion, if a marble was drawn from rest and at the same height, and another marble was projected horizontally at 0.2 meters per second at the same time as the first marble, both marbles will have an equal acceleration, as gravity causes both to be pulled downwards at 9.8 meters per second squared. Even though one marble is launched horizontally at 87 meters per second, this velocity does not interact or interfere with the downward acceleration caused by gravity, and due to the negligence of air resistance, both marbles will strike the ground at the same time. This is because the vertical velocity and the horizontal velocity act independently of one another. Therefore, regardless of horizontal velocity, both marbles will accelerate downwards at the same rate. And if the initial horizontal velocity of the marble projected increase, the distance traveled will increase in the same length of time. Instead of traveling 0.2 meters per second, it could travel even further. The greater the horizontal velocity, the more distance an object can traverse in a limited time period. The time of flight will stay the same, as stated above. The horizontal and vertical velocity are independent of each other. This means that the object will continue falling at the same rate and strike the ground at the same time as in the previous areas. The vertical motion of the marble being projected horizontally can be described as accelerating downward, as gravity is constantly causing a downward acceleration. The horizontal motion of the marble being projected horizontally can be described as a constant speed, since no further force can act upon it to change the horizontal speed. Therefore, this is the conclusion of our projectile motion lab, and I hope you have fun.